I'm back, I'm Kisha, and today we'll be identifying my latitude with the use of Polaris and a DIY sextant. On our last vlog, we identified our latitude and longitude with the use of solar declination as well as the shadow stick method. And today, we'll be identifying our latitude with the use of Polaris or the North Star and the DIY sextant. Before we start, let's first clarify some terms. Terms like Polaris, horizon, sextant, and latitude. So first up here is the Polaris. Polaris or North Star. So Polaris or North Star is a bright star that stays fixed in the sky and it rests directly above the North Pole. So since it is permanent or fixed, it is used as a permanent marker to find the North. Second one is the horizon. So horizon is a far-off line where the sky appears to meet the sea or the ground. And actually it is our eye level when looking or sighting across the earth. Third one is the sextant. Sextant is the handheld tool used to measure the angle between the horizon and a star, or in our case, the Polaris. And lastly is the latitude. Latitude is the measurement of the north or the south, or south to north of the equator. So now I'm discussing the brief steps in performing our fieldwork. So first one is to prepare the materials needed in our fieldwork. Second one is to create the DIY sextant using the materials that we had prepared. Third one is to find a right place where we could sight the Polaris. And we can note that we could sight before the dawn or during the night as long as the celestial bodies are present and visible. Fourth one is to make sure that the string before sighting is in 90 degrees because it is our level sight. Fifth one is to take 5 readings and getting the average of it. Sixth one is to compute for the latitude with the use of formula. Latitude is equal to 90 degree minus the mean reading or the average readings. Since we know what to do, now let's make our DIY sextant. So the materials that we'll be needing here are the glue, a piece of string, tape, scissors, a protractor. But since I have a small protractor, I printed a template. This template will be stick here on a spare 1/8 illustration board to make it sturdy, like this. And then I'll cut it, and a piece of bond paper wherein I could roll this and sight it like that.
So as you can see guys, I just pasted the protractor template on the 1/8 illustration board and then I cut it down. And then after doing that, I rolled a piece of bond paper so that I could make a telescope. And I glue it up and tape it. After doing it, I created a really tiny hole on the protractor so that I could put the string on it. And then I just pasted the two, the telescope and the protractor. Now we need to tie up the scotch tape on the string so that it could hold the weight of it and stay in the 90 degrees.
So during our fieldwork here, we need to take down notes and calculating. So we need a calculator, a pen, and a paper, of course. Go. Good evening everyone. So tonight it's already 9:30 p.m. and I am surveying the celestial body, the night sky, and as you can see there is no star. Even the North Star, the Polaris, is kinda, I think it's showing. However, it is really cloudy here, so I can't really find the North Star. So I'll try tomorrow to let's see if I'll find the North Star so that I could point my exact or my approximate latitude still with the use of my DIY sextant. So everyone, so today it's already 5 a.m. and the cloud in the sky is still there. However, sometimes the Polaris is still showing up. So we need to wait and let's have a good timing so that we could sight it like that. So guys, can you see that star? I think that's the Polaris. Let's zoom in. Yeah, oh my gosh, that's the stars. So there are stars now. We need to first find the north. We got 74.5, so for first we need to have 74.5 degrees. So got 74 degrees. We got 74.5. We got 75, guys. We got 74.5. here's what we got for the first reading, second, third, fourth, fifth. Then we need to get the average of this and divide it. Get the average of this, and we'll use the formula latitude is equal to 90 degrees minus the mean of this or the average of this. So let's go on solve this. There's an airplane. There's an airplane, guys. Oh my god. Airplane, a morning plane. I thought it is a Polaris, but it's not. So now that we got the data that we needed, I will now be showing you how did I do the computation. So this is the DIY sextant that we made. So as you can see, most of here ranging from 74.5, 74 to 75, and it is more likely here, something like here. So I recorded it as a decimal, so I just converted it into degrees and minutes. So for first reading, we got 74 degrees and 30 minutes. For the second one, we got 74 degrees. Third one is 74 degrees and 30 minutes. For the fourth one, we got 75 degrees. And for the last fifth reading is 74 degrees and 30 minutes. And if you will sum it all up, it will be equal to 372 degrees and 30 minutes. So I'll be showing you how. So we got 372 degrees and 30 minutes. So I'll now divide it by 2, 4, 5. So we have 5 readings, so we'll divide it by 5. So we got 74 degrees and 30 minutes. So for the formula of computing the latitude, we have latitude is equal to 90 degrees minus the mean readings or the average reading. So we need to plug this value here. So latitude is equal to 90 degrees minus 74 degrees and 30 minutes. So now the latitude will now be equal to 15 degrees and 30 minutes north, since the Polaris is in the north. So in conclusion, we got a latitude of 15 degrees and 30 minutes north with just the use of this DIY sextant that we made. And I could also conclude that without the use of global positioning system, we could easily identify or approximate our latitude as well as our longitude. Again, see you next time.